Okay, good thing. All right, you. All right. Well, welcome everybody. We're gonna kick off this session. First, I'd like to welcome those who are here in the room. You need more volume, a bit louder, please. Yeah. So, firstly, thank you for joining us here today, physically and both virtually on YouTube. I'd like to provide a bit of context first on this event. So there's a lot of discussions about carbon dioxide removal, perhaps not officially in the COP sort of negotiations, but definitely around it. And a lot of those conversations are on how much we need carbon dioxide removal. The models are all reliant on a significant amount of carbon dioxide removal. So we've been involved in a European Horizon 2020 project called NEGEM, where the objective of the project is to look at the opposite side of the coin, looking instead at how much we can supply realistically, which we think is quite an important question to look at. So I guess you don't really want to listen to me, you want to listen to the NEGEM experts. So we have Marzan here with us physically, and we have Kati Koponen, senior scientist at VTT, and Wolfgang Lucht from the Potsdam Institute of Climate Impact Research, who are both with us on Zoom remotely. So can I ask Kati to please start her presentation?
Yes.
So
Thank you, Mark.
You have to share your screen.
Yes, I'm. Can you see it now?
Oh, all right.
So is it fine now? Great.
So we see presenter mode.
Yeah, great. So thank you very much, Mark, for the introduction, and good afternoon from my behalf to everyone. So I'm going to give you a general overview of our NEGEM project. So assessing, yes?
Yeah, we're seeing your presenter mode. If you could put your
okay,
normal...
so let's...
Yeah. Yep, excellent, thanks.
Great, okay, thanks. Okay, so yes, as said, NEGEM is about assessing the realistic potential of carbon dioxide removal and its contribution to achieving climate neutrality. And as Mark said, this is a Horizon 2020 funded project and running for 4 years, and we are currently in the second year of the project. So here you can see a simplified illustration of an IPCC 1.5 degree middle of the road scenario. And as we all know, the net zero emission should be reached by the mid of the century. And in the figure, you can see that to reach the net zero, negative emissions are already likely needed. So these negative emissions will balance the emissions that are very difficult and hard to abate from other sectors. And by the end of the century, the role of the negative emissions in these scenarios is even more emphasized. And as Mark said, in these scenarios, this need for the negative emissions is often demand-based. So we have some mitigation target, and then the models give us the amount of negative emissions that are needed to achieve this target. But in our NEGEM project, we have a little bit different approach, and we want to understand what is the realistic potential of negative emission technologies and practices. So when we have this theoretical potential of negative emissions, and then we take into account the different limitations and constraints, so they can be technological, they can be commercial, environmental, or social. And by taking them into account, we want to understand what would be this realistic potential for the sustainable deployment of negative emissions. And in the second phase of the project, we also want to understand how to meet then this realistic potential of negative emission technologies and practices. So how could country portfolios look like in the EU member states? what would be the EU-wide potential, and how should this be governed so that we can go for these sustainable pathways for climate neutrality. In our project, we have an excellent consortium, so altogether 16 partners from 11 countries, and also including 5 industrial partners. So negative emissions can be created in many different ways. Some of them are more nature-based solutions, and some of them are more engineered solutions. And in our NEGEM project, we try to include as many of these technologies and practices as possible into our assessment. In addition, there are 2 other Horizon 2020 projects called Landmark, which is concentrating on the land and biomass-based solutions especially, and then OceanNets, that's concentrating on the ocean-based solutions. And we are in close cooperation with these two other Horizon projects. What all these technologies and practices should do is that they should physically remove the CO2 from the atmosphere, and then the CO2 should be stored in a manner that is intended to be permanent. In addition, we need to include the impacts and emissions created during this capture and storage process, and the whole balance of these emissions should be negative. As said, these negative emission technologies are likely needed to ensure our planetary boundary for climate change, but at the same time, they can put pressure on other planetary and regional boundaries. And Wolfgang in his presentation is going to tell you a lot more about this aspect. And this is an example of a way how we want to understand these limitations and include them in our NEGEM analysis. In addition to the environmental and technical barriers, there might be some social and governance barriers related to the negative emission technologies. So in one of the NEGEM workshops, we asked the audience what would they consider as the main barriers for the negative emission technologies and practices. And the 2 main answers were the economic performance of these technologies and practices, and also the lack of common European policy framework. We also then asked what kind of instruments would be needed for these practices to be deployed. And these, again, 2 answers were highlighted. So the financial instruments such as taxes and subsidies, and also developing market mechanisms for these technologies. And today, Miles is going to concentrate on the market mechanisms. So there are many different challenges related to this issue, and in NEGEM, we hope to provide as many answers as possible. So I wanted to share with you some of the key outputs of our project this far. So these have been already published in our website, so you can find them from there. So there are several sustainability assessments on terrestrial, marine, and bioenergy plus CCS-based technologies. So these are case studies studied with life cycle assessment type of approach. So the environmental performance of these technologies is assessed by several indicators, and also some economic indicators are included. In addition, we have published 2 databases. So one on the technologies and cost data, and another one on biogeophysical database. So there is data on land use, land cover, geological storages, and etc. and so on. So these 2 databases will be used in our NEGEM studies, and they will be also updated during the project. In addition, we have published a report of a stock taking of 1.5 and 2 degrees mitigation scenarios with negative emission technologies, and what is the role of these technologies in these scenarios. And here we concentrated especially on the gray literature, such as the IEA scenarios and the EU-wide scenarios, as well as the member states' plans for negative emissions. In addition to this, many interesting outputs will come very soon. So during this autumn, we will already publish studies on interactions and trade-offs between nature-based and engineered climate change solutions, and survey on commercialization mechanisms, a study on social license to operate of these technologies, and a study on negative emission governance. In addition, there will be a study on the principles of carbon negative accounting. So all these will be published in our website, and I invite you to follow us and our progress in our website, and please don't hesitate to contact if you have any questions about our projects. So that was the general info about our project, and I now hope that we can move on to these very, very interesting topics that we have with Wolfgang and Miles today. Thanks.
Great. Thank you very much, Kati. I guess I might just take one or two questions from the audience if there are any. If not, we can move on to the next presentation. Yeah, there's a microphone right here. Would you mind coming? Yeah. Great, thanks.
Finnish Innovation Fund, Sitra. Regarding the role of negative emission technologies in modeling, my understanding has been that the technology portfolio included in most modeling scenarios has been rather limited. Can you perhaps talk about how you see that developing in the future and how that might affect the results?
Yes, so it's clear that it has been limited in the recent scenarios. So mostly bioenergy with carbon capture and afforestation has been included. Also some direct air capture and enhanced weathering. But well, I think it's clear that we need to enlarge this portfolio because the sustainability issues are worse when we have only a couple of options included in the scenarios. But if we can have several options, then there is less pressure on one negative emission option, and then maybe we can have less negative impacts also created or unwanted impacts.
Great, thank you, Kati. Would you mind if you could stop sharing your screen, and then we'll.
Thanks.
Great, people. Cool. So next, Professor Miles Allen from the University of Oxford.
Okay, so can I just check also that maybe Kati and Wolfgang could tell me if they can't hear me on Zoom? I guess somebody would say, okay, I'm assuming it's working out all right. Okay, there we go, good. But by the way, on the point about NEGM is also working with the integrated assessment modeling community through Wolfgang. So I think Wolfgang can probably tell us a bit more about that. I know there's a few people here from PIC, I noticed. So I wanted to talk to you about one quite specific thing that we've been doing under work package 2, which is the commercialization pathways for negative emissions in Oxford, and some work I've been doing with Eli Mitchell-Larsen on this project. Eli, who is still with the University of Oxford, but is also with Carbon Gap at the moment. So that's, can we just advance the slides? Just one more. I'll just ask you to put the clicker doesn't need to work. So first of all, there's a lot of interest at the moment in the re-emergence of carbon markets and voluntary carbon markets and compliance markets under Article 6. And this is some sort of the key performance indicators we need to think about in carbon markets. I've been quite heavily involved in the task force for scaling voluntary carbon markets, and these are the kind of questions that were being asked there. By the way, I'm very happy for my slides to get put up on the web, so I'm sure Bellona will be able to make them available to people. And these are basic questions we've got to answer. Is the market itself as a whole, are these transactions delivering emission reductions? First of all, if a carbon market is being used, if you're buying avoided emissions against some baseline, then what is the baseline against which these emission reductions is being measured? In a world where everybody's heading for net zero, that baseline starts to become really quite important, and also many transactions that might be proposed under a carbon market mechanism. I'm straying here into deep Article 6 territory, but I just want to point out there's an issue here, and it's not one I'm going to solve for you in this quick talk. An important question, which I think is often not talked about in the voluntary carbon market discussions, and perhaps also, dare I say it, in Article 6, is what the impact of the existence of the market has on the buyer. Does a company that, because there is a market out there, does the company relax and not actually reduce its emissions by as much as it could? Or does even a country relax and not reduce its emissions by as much as it could? And then the second big question is the market itself facilitating the transition to net zero? Is it actually helping us build the investment strategies we need, and indeed guiding the collective nationally determined contributions towards net zero as we could? If we go to the next slide, there's a whole complex tree structure of offsets that are, you know, and I know that Article 6 people say, well, Article 6 is not about offsets. Well, okay, I'm using the word offset in a very general sense, a sort of intuitive person in the street sense of offset here. And so I hope we won't get bogged down in really sort of wordsmithing what you can. I'm calling all this stuff offsetting. And this is a tree structure that we came up with in the Oxford Principles for Net Zero Aligned Offsetting, published last year, which allows you to categorize how an offset would work in a carbon market. And the important point is you have this transition going from brown to blue here, a transition between avoided emissions on the one hand, emission reductions through nature-based, mostly nature-based removals, emissions reductions with short-lived and long-lived storage, carbon removal with short-lived storage, that would be nature-based carbon removal. And then over here, carbon removal with long-lived storage. So it's kind of a progression across this diagram. And these sort of examples of these over here would be that 85% of current voluntary carbon markets, at least, are in this first category. This is where you're basically paying somebody to avoid emitting against some baseline. So these are sort of the avoided emissions category. And normally that's like you're paying for avoided deforestation. There's no obvious storage of the carbon that is avoided there. So it's sort of avoided emissions without storage or with no long-term storage. Then of course we have, you know, so either without or with short-lived storage where it's deforestation. There's another interesting category that people don't talk about, but I think maybe we should start thinking about, was if you have a market which is paying for avoided emissions, you wanted to do two things. You wanted to promote technologies that will be needed in the transition to net zero, and you wanted to reduce emissions. And so you could argue there is a case for a class of offsets where you're paying for avoided emissions with long-term storage. What would that look like? Paying for a power station in a developing country to fit CCS and pump that carbon dioxide back underground. That would clearly be additional because it wouldn't happen anyway, particularly if it's a developing, you know, if it's a developing country which hasn't got to the stage of, you know, embarking on CCS. But that would be quite a controversial offset. As you know, I can imagine plenty of controversy over such an offset. But maybe we should open the conversation as to whether or not that would be a good idea. Then we've got the category of offsets that everybody likes to talk about. There's the carbon removal with, and we're calling it here carbon removal with short-lived storage. We're defining here short-lived as anything which has a time scale or risk of reversal shorter than 100 years, into which pretty much all the biological offset options would fit. So afforestation, blue carbon, and so forth, soil biochar, soil carbon restoration, and so on. We don't know how short-lived the storage is there, but you know, we know that it's sub 100 years. And then there's the carbon removal with long-lived storage, which is the, air capture geological storage underground, which of course, it needs verification and so forth, but there is, at least in principle, scope there for ensuring that that carbon dioxide is literally taken out of the atmosphere, squirreled away back underground. If we go to the next slide, the challenge we face is that sort of we are here now. We're sort of working with these categories of avoided emissions and carbon removal with short-lived storage. So afforestation, if you like, think of this. And I probably shouldn't wave my hands near it or something. Is that what happens here? And avoided emissions here. That's what all of the market is about this. And yet, if we're to achieve a durable net zero by 2050, all of the market has to be in that blue category, that any remaining fossil fuel use in 2050 has to be compensated for by air capture with geological storage. We can't turn rocks into trees forever. That can't be said often enough at this COP. That's one thing. If you take nothing away from this talk, apart from when you go out there, point out to people, by the way, we can't turn rocks into trees forever, and see what they say. And the other important thing to say is we have to stop climate change before the world stops using fossil fuels. We don't have time to wait for the world to stop using fossil fuels before we stop climate change. Say that as well as often as you can in this COP, because that's another message that isn't getting through. So we need to get to this situation, and we are here now, but we also don't want to lose the opportunities that are provided by all these lower cost and with many co-benefits offsetting opportunities that we have in the short term. So if we go to the next slide, this is the challenge we face. I can't say it often enough. We have to stop fossil fuels from causing global warming before the world stops using fossil fuels. Offsets, therefore, or something like them, they might be called insets, they might be called just compensation or whatever, they will still have a role, a vital role to play in a net zero world, compensating for ongoing fossil fuel use. But it will be, to sort of quote Star Trek, it'll be offsets, but not as we know it. They will be overwhelming, they will have to be entirely air capture from the atmosphere in one form or another, and geological timescale disposal. But in the short term, and already in the voluntary markets, companies are starting to buy this kind of offset. But it's companies with very deep pockets, and they're not buying very much of them. They're buying a few tons. So the likes of Climeworks are already offering this for sale, but it's not the bulk of the offset market. So how do we capture the benefits of the, as it were, more traditional forms of offsetting, and with the need to transition to this permanent storage? Our proposal, and this is a paper I would have liked to have been announcing this. Journals take a long time, but we're very happy to provide you with a preprint of this paper between Eli and myself, looking at this, in which we suggest an explicit way of designing, of addressing this challenge in the offset market. But let me just give you the overall principle here. We need a transitional offset strategy. We need companies that are using offsets, and we'd like to think maybe countries using international markets also, to explain how their strategy is going to transition to long-term durable storage. If they're using short-term storage initially, they need to map out the pathway of the transition. And if we go to the next slide, we actually suggested in this paper, which I'm happy to share with people if they want to follow up, a way you could actually package the transition into an offset product. We suggested the term PROSET, for progressive offset, meaning an offset in which the fraction that is permanently stored underground increases progressively over time, so that you guarantee that by a certain date in the future, it is 100% air capture with permanent geological storage. And you could sort of create this as a financial instrument to ensure that that transition occurs, and that the very much needed that permanent storage is not crowded out by the equally needed short-term storage that we need now to address some of the challenges we have in the biosphere. If we go to the next slide, and I will wrap up in a minute. This shows how we could define a process here. It's called a second order process because the fraction which we store geologically goes up quadratically. You can make it a third order process if you want to, but I wouldn't approve of it because that's sort of really backloading the problem. Anyway, we can get into nitty gritty of that, but this is sort of reasonable way of defining it. And crucially, this initially isn't much more expensive than a conventional offset because most of it to start with is just your standard nature-based solutions that are relatively cheap at the moment. But you guarantee as part of the product you're selling that fraction that is stored back permanently underground goes up over time. And this might be a way of actually enlisting interest in offsetting into ensuring we actually get this transition rather than the danger I think we have at the moment, which is that offsetting with temporary storage solutions might actually just get in the way of the need to develop long-term storage at the moment. I mean, we can have a healthy debate, I'm sure, about whether that would happen, but that's the concern. Finally, I think we're done. Yes, that's right. So we'll take questions, I guess, at the end, because I think I just went over my time, and then so Wolfgang could come in, and then we can take questions with everybody. Yep.
Cool. Great.
Apologies, Wolfgang. The game started too long.
So yeah, Wolfgang, if you
could,
can you hear us? Yes.
Okay, so thanks for giving me the opportunity to present some results. I'll mainly be looking at the limits that Planetary Boundaries bases on biomass-based carbon dioxide removal, and I'll show you a few unpublished, very new, soon-to-be published results on the biochar angle. So this topic of carbon dioxide removal, I thought it was maybe useful to give a perspective, our perspective on why it's even a topic, because we all know how controversial it is, strategically, politically. So I think it's an important topic, first of all, for balancing unavoidable and hard to abate emissions, which we will have, so we will need to do something for those. The question, of course, is how do you define unavoidable and hard to abate? How do you prevent, any emission that is too costly or too just inconvenient for a company to be called unavoidable? Then there's overshoot drawdown. We might shoot over the targets and want to get back down. Carbon dioxide removal would be very important for that. Then, of course, it's not completely out of the question that we might actually not succeed and that we might really find ourselves in a climate emergency in a whole nother dimension. We can see escalating breakdown and then emergency, an emergency kind of, can we fix at least part of it mode might be important. But then also, maybe we want to get back to 350 ppm eventually, because that's the really safe Holocene state. Maybe we don't want to be satisfied with 450 or 550 in the long term. So those are the reasons why even looking at the issue. Now, in my personal opinion, and I'm sure it's widely shared, CDR is not to compensate for continued fossil fuel use. It should not distract from going to 100% renewables and putting the push there. A push for CDR is justified, as I said in the first part, but it should not come at the cost of pushing for 100% renewables. And it should not greenwash lacking mitigation, of course. And the reasons for that are the potential of CDR is probably limited. We don't quite know what the limitations are. We very easily speak about geological storage now. Right now a lot of it is quite theoretical and speculative. You still have to see what it will be in practice. And the impacts, at least for the biology-based CDR, are substantial. Most of it is completely unproven at any relevant scale, so it's a bit of a speculation on the future. But CDR plays a big role in the discussion because these, as we saw, the global climate economic pathway models use it quite a lot. And the main reason is that from their perspective, being economic models, it is cost effective. They're looking for paths that the economy can take. And in those paths with a certain cost profile, CDR is part of economically viable paths. So the mantra is it's cost effective. But then also, at least here in Germany, politics are using it to cover for past delays and insufficient action. So they want to say politically that we are on track, even though our carbon budgets are being exceeded. And so usually not explicitly, but implicitly, they refer to paths that actually contain a lot of CDR. And then there's, of course, the realists who think and have good reasons for thinking that we will not be able realistically to reach targets without CDR. Their mantra is, but we need it, which of course is, again, demand side thinking, and we are interested in supply side thinking. So overall, it might be true, it's conceivable that we might need it eventually, not just for the hard to abate emissions, but that we might need CDR down the road. But we should never forget that not just burdening the future generations or even the young generations with the impacts of climate change is putting an unjust burden that constitutional courts are looking into now onto that generation, but also that expectation that for somehow they will install these global systems for CDR also puts a burden on them that they will have no choice over. So it's interesting to also look at it from that intertemporal justice perspective, and let's see whether the courts pick that up at some point. So these are the 1.5 degrees paths that the SR15 of the IPCC has presented us with, and they all have net zero around the middle of the century, and you can see these negative emission potentials or demands that they have. This is the demand side. So in order to reach that climate goal, they require 5 to 15 gigatons of CO2 extraction per year, going up to 20 in the most extreme scenarios, which are huge numbers. If you compare those with the size of the global land sink, today, net, it's about 7 gigatons of CO2 per year. And the size of the current global ocean sink of those 2/3 of the land of the global surface that are oceans, that's about 10 gigatons of CO2 per year. So you can see that in such a seemingly harmless solutions figure from the economic models, the negative emissions, the CDR needed, is of the same magnitude as the current land and ocean sinks, if not larger, that we now need to artificially create on top of it all. So we are talking about a huge planetary engineering project, and just calling it CDR and stuff like that is maybe sometimes not admitting how large that scale is. Now, currently, as was already mentioned, most of the CDRs assumed to be delivered, at least in the first phase, by biomass plus geological storage, called BECCS. And mainly the reason for that is it's assumed to be cheap, because all the stuff on the land is kind of doesn't break the bank. It's assumed to be green because it has to do with biomass. And it's often called, as we've heard, nature-based solutions, a term I really don't like, because it's based on nature only in the most general sense that it's using photosynthesis. But a lot of this stuff really is industrial scale, fertilized, irrigated, intensely managed monoculture, biomass production for getting as much biomass and carbon as possible. That is not really nature, and the plantations don't look like nature either. So I personally object to calling it nature-based solutions. Now, that CO2 extraction, of course, is meant to alleviate pressures on the planetary boundary for climate change. So we're already in the risky zone with that boundary. We are heading towards the dangerous zone, and CDR is going to counter that and will not get us back to the safe zone for now, but at least prevent us sliding even further into that. But there are other planetary boundaries, and in the end, you need to stabilize Earth in the Anthropocene as a whole. And at least for biomass-based CDR, that because it requires land, it requires water, it's a part of the carbon cycle. As we improve the climate boundary, other planetary boundaries are likely to be negatively impacted. It increases the pressure on other planetary boundaries, and those other boundaries many of them are already transgressed, or we are approaching the boundaries. And the main reason is that agriculture, land use today is already, the main factor in transgressing planetary boundaries. We're already beyond the safe space, mainly due to agriculture. So a stabilized Earth is more than just stabilized climate. And so any CDR that we do on land, biomass-based CDR, has to fit into this overall picture of stabilizing Earth. So what is the potential of BECCS that is compatible with the planetary boundaries concept? So we published a paper on that in 2018, and in the course of the NEGM project, we are going to do a substantial update of this paper, with much better scenarios and a much more detailed analysis. We're working on that. It'll still take some time to get it finished. But our finding at that paper back then was that there is basically no wiggle room. You can see the paper is called Biomass-Based Negative Emissions Difficult to Reconcile with Planetary Boundaries. And again, it's mainly because land use already today is transgressing the planetary boundaries. So we didn't look at it from that global perspective, then the wiggle room would be zero, but we looked at it regionally, because of course, in some regions, maybe something can be done without ruining those regions. Now the image is quite complicated. I won't explain it here, but the finding basically is that the more CDR you do, the more you exert pressure on those planetary boundaries in several important dimensions, making things worse. So there's important trade-offs that really limit what can be done if you look at the whole system. And so then you get to that topic of how do we reduce pressures in other ways? How do we reform the whole agricultural system? How do we feed 10 billion within planetary boundaries? And can CDR be somehow integrated as a mosaic part into the system? And one way in which this might be possible is by using biochar. So what happens in biochar is you have the biomass, and then you put it through the pyrolysis process to turn it into char, and you basically get three products: biogas that can be used for energy, bio-oils that you can either use for something or you can sequester in storage, and biochar. And the idea is that if you apply that biochar to local croplands, then a lot of field studies show that actually, at least in the tropics, you can get a yield increase of around 20%. Of course, it depends a lot on the conditions and on what else you do with fertilization and so on, but there is a potential for increasing yields. And so that opens up the potential that since you can increase the yields, you can produce the same calories on less land, and the land that you free up, you can lose for producing the biomass. So in that sense, the system would be something that we call land neutral and calories neutral pyrolysis CCS. So that's a biochar route that would, use the land, some land, to produce biochar, and with the biochar, increase the yield on the remaining land so that overall you produce the same calories on the same land, but you also have the biochar that fixes carbon in the soils. And so the question is, how much, is that a system that can actually deliver something, a meaningful quantity of CDR? And so these are results I'm going to show you to close my talk that have not been published yet, but we hope to submit the paper next week. The work was done by Constanze Werner, who was employed by the NEGM project, on land and calories neutral PYCS, as we call it, pyrolysis with CCS. And so the graph is kind of supposed to suggest that if you have a BECCS scenario as the economic models foresee it, but some of that BECCS you don't actually need because you do it land and calories neutral through biochar. And then you basically free up some land that otherwise you would need for BECCS if you follow the demand scenario. And there are two things you can do with that land. Either you can just use it for nature protection, and in Kunming, in the CBD process, we are talking about nature restoration, of course, or we can increase calories production. So we can produce more food because we have additional land not needed for BECCS. And so we put all that through our very detailed, long established biogeochemical biosphere model, LPJ-ML, which computes the carbon, nitrogen, and water cycles. It simulates vegetation growth and structure for both natural vegetation and agriculture. And it has representations of biomass plantations that are actually geared towards what the field studies show. And they take in climate scenarios, the land use scenarios, with all the trade-offs involved in land use patterns, and the biomass plantations. And it computes the theoretical CDR potentials and the impacts on the planetary boundaries, and quantifies trade-offs that are involved between those planetary boundaries. And so what we find is that in a completely land neutral and calories neutral way, we could sequester between roughly 0.5 and 2.5 gigatons of CO2 per year. The variation has its origin in the question about how much can you increase yield by the fertilization. We made 3 scenarios, one with 15% yield increase, 20%, and 30%. Something like 15 to 20% is seen in field studies in the tropics. That's what the meta-analyses show. 30% would be if you combine that with additional stuff that boosts yield. But you can see on the left side that you can see all these IPCC scenarios with these huge negative emissions demands. So it would only cover a small fraction of that, a constant fraction of that, because once it's implemented, it's done. But that fraction you could actually do on a small scale. So this is not industrial big stuff. This is farmers could do it as carbon farmers. If there was some sort of financial scheme attached to it, they could just use that and not lose any productivity of their fields, but have this as additional income. The supply would be between 6 and 36% of the demand that the economic models see for the 2-degree target, or 5 to 28% of the 1.5 degrees target. Of that demand. And then the land that is spared because of that, because you need less BECCS on additional land, you could either produce 2 to 16% of additional calories, which is quite significant because we'll have 2 billion more people and more demand, or you could product up to about 100 million hectares of nature, of land you could actually leave to nature protection, or you could restore lands rather than using them for BECCS. So while this is only a contribution, it's not a small contribution. So the conclusions are, when you consider CDR, and it should here say really land-based, biomass-based CDR, you should do so for good reasons. Because other than maybe DAX and geological storage, the biomass-based CDR is happening on that same one planet. And so it has impacts on that planet. And since you're talking about reproducing something of the magnitude of the global land or ocean sinks, it's a huge planetary engineering project. We've written papers calling it biogeoengineering because you're engineering the carbon cycle here. And you should not just consider climate, but all planetary boundaries, which all have to be considered for stabilizing Earth. The potential of BECCS within planetary boundaries is quite small. So to the extent that we have to do it, CDR, it should not say previous, it said CDR is precious, it's valuable, and it should be used judiciously. So it's not something you can use, just because you have the money, but you should really use it in those places where it actually is needed the most. Biochar offers a local and regional scale pathway that could be land and calories neutral in the tropics, but as a service to the globe and generate some regional scale income. The potential is on the order of 1 to 1.5 gigatons CO2 per year. So it's significant, but only 50 to 20% of the demand that transition scenarios see. So this is the supply side, a supply side that minimizes the side effects on the biosphere. So the final conclusion is beware of demand side CDR analysis. We also need to look at the supply. And that is, of course, the demand side and the supply side, bringing those together into one framework of analysis. That's, of course, something that we will do in the next 2 years in the NEGEM project. So thanks.
Great. Thanks. Well, Wolfgang, if you could, stop sharing the screen and then. Speakers on the oh, it doesn't matter. All right. So first question.
So sorry. Tim Kruger, Oxford University. Thank you to all the speakers. Got a question for all of the speakers, but really probably to Wolfgang, because he just left on that final note, which was saying that we should be looking at the supply side rather than the demand side, which is what NEGEM is all about. He's rightly criticized some of the aspects about BECCS, for example. Should we actually just remove all negative emissions from the models until and unless we actually have some sort of evidence base for the degree to which they could be deployed?
No, I think analysis is important. And in the beginning of the talk, I gave some reasons why CDR probably will be needed for certain things. But in my personal opinion, what we should guard against is to misuse that it gets misused for delay and inaction, or it gets misused politically or in an intransparent manner. And the NEGEM project is not saying, you know, go only to the supply side, but it's saying it's about realistic potentials. So,
but if we don't know what the realism is, surely the cautious and proper and scientific thing to do would be to exclude them from the models until and unless we have evidence. Surely, otherwise, we're misleading ourselves, as you say.
Yes, I mean, to be very frank, I think there was a big problem when the SR15 was planned, because, I mean, what was the IPCC supposed to say? Were they supposed to say 1.5 isn't possible anymore, or only at atrocious costs and disruptions? Or were they to say, no, there still is a path? And then from a purely economic perspective, where you trade off, you know, mitigation costs against CDR costs, and you have some assumption about cost profiles and technological process, then in the framework of that analysis, you know, these paths could still be achieved. And now the big question is how much of that is real and how much of that is reliable. And I mean, there's a huge discussion, and I think we will have it when the Working Group 3 report of the AR6 comes out. You know, what do we do with it politically? So I think as analysis, I mean, this is good science. This is completely valid. And, you know, if there is this well-justified demand, which is not just for cheap reasons, but for very well-founded reasons, then, you know, it's a challenge. But that doesn't necessarily mean that you get your wishes fulfilled. So I think the question is how the complexity of that discussion translates into the public and the political arena. I personally am quite skeptical. I personally would be very, very hopeful if we could manage with a huge effort to cover the hard to abate and unavoidable remaining emissions. And the question is what falls under that. But I think that already would be a huge challenge till 2050 to get that going. And I'd be really relieved if we could manage that. I don't know if there's much on top of it, but that also requires the full spectrum. But I might be surprised by technological progress. I tend to be doubtful, but others are hopeful. And, you know, we don't know who's right. So it needs to be explored scientifically, but strategically, the communication has to be done very carefully, which is why NEGEM put such a focus on two things. One, on the accounting and how to talk about these things. And on the other hand, on the dynamics of the markets, which Miles was talking about. How do you construct a system that is honest, transparent, and has mechanisms that kind of lead it in the right direction? And that's not a trivial thing to ask.
I chip in on that as well. There's a couple of points. First of all, if you actually look at the integrated assessment model scenarios and their costs of BECCS in the scenarios, it depends very much on the model you look at. And this is not, there may be all the people in the room are greater specialists in this. They are actually assuming quite high costs of BECCS, up at the sort of, you know, $200 per ton by the time you get to 2050. So I think it's a reasonable thought experiment to say, what if we had a negative emission technology that was of that sort of price? If these models are putting in BECCS at $10 a ton of CO2, then I agree, that's just ridiculous, but they're not. They are actually putting quite substantial. So I think what the models are using BECCS for is this generic, you know, suppose there's a negative emission technology available, what would, you know, what does the model suggest the most cost-effective pathway is? The second point I wanted to pick up on Wolfgang's point about the accounting, and this is quite a philosophical one, and one which we are rather grappling with in NEGEM, is, you know, does the annual accounting which we're quite good at, or at least we think we're good at, we sort of focus on at least. You know, how do you, and we aren't done yet, and we haven't actually incorporated negative emissions properly into our annual accounting systems for greenhouse gases. But there's another problem that we haven't really started thinking about yet, which is the centennial accounting of negative emissions. You know, because that's what the climate in 2100 will see, not what we did in each individual year. It'll see the aggregate of the carbon which was actually dumped in the atmosphere versus put back underground and so on. And so one of the things I think that we need to be thinking about collectively both as an academic community, but also encouraging policymakers and the public to think about is, where do we want all this carbon to end up? You know, when we're in 2100, what forms do we want all this carbon to take? How much of it do we envisage? Clearly, it would be nice if it was all just underground, because we discovered cheap fusion next year and we just stopped using fossil fuels, because, you know, there you go, it might happen, but it's high risk to assume that's going to happen. And if that doesn't happen, you know, how is it to be distributed over the century as a whole? And this has a practical implication, because just to pick up on one thing which Wolfgang said at the end, reserving negative emissions for critical applications makes a lot of sense. On the other hand, using negative emissions for what you might call frivolous applications, if it means the frivolous application increases the supply of negative emissions in the future by paying for technology development, that could be a good thing. And where is that balance? I'm not sure we're asking ourselves that question enough. So for me, if Elon Musk buys negative emissions to offset his space tourism business, is it he's got one, or Bezos? They all have them. Okay, is that frivolous? Well, I mean, yes, no, yeah, okay, we got some nods there, but is that a good thing? Maybe if they're willing to spend $1,000 a ton of CO2 to drive the technology and to drive enterprises being set up to develop negative emissions solutions, then if that results in more negative emissions capability being available in the 30 years time when we're really going to need it, maybe that's a good thing. And we've seen other examples in the past where early adopters, you could say, are just doing it for fun. But you know, we've ended up with a necessary technology as a result of this relatively frivolous early use. And you know, I think these are questions we need to ask ourselves about what is the right century timescale balance to be considering there. So I was, as you can tell, we have a spectrum of views in the NEGM consortium, which always makes for a lively European. And so I don't know whether Wolfgang wants to come back on any of what I've just said, or whether we should take another question.
Well, I'll first go back to the audience, see if there's a question. Unless, Wolfgang, you have a immediate result. No? Okay. Are there any questions in the audience? Yeah, okay. Would you mind coming? Yeah. Sorry, it doesn't extend that far, unfortunately.
I want to ask in the context of that's in the context of drugs, for example, saying it's be positive in terms of its emissions using biomass rather than, yeah. And how do you line up in terms of having biomass as part of a sustainable investment taxonomy?
Yes. Now, seeing as, you know, we're not supposed to offend our hosts, are we? But then I'm a citizen of the host country, so I'm allowed to offend the host. And so there's a lot of interesting decisions and challenging decisions that our government's going to have to make over the next few months, indeed, on the negative emissions space. And a big one is going to be what they do about tracks. So just for those who are not familiar with this project, we have a very large power station, 13% of the UK's baseload electricity, using, I can't remember what fraction of biomass at the moment, but it is proposed to become one of the anchor supplies of CO2 to our Humber cluster driving the development of a CCS infrastructure into the North Sea to start getting rid of CO2, and they need baseload CO2 supply for that cluster, and Drax is a very obvious candidate to provide that guaranteed supply of CO2 to put into the pipeline to go back under the North Sea. But this, of course, means licensing Drax as a negative emissions facility when the overall carbon accounting, I don't want to get into the debate about the exact carbon accounting of Drax because you have strongly held views on both sides, and I suspect there are people in the room, but I get it that there are questions that can be asked on both sides of that equation as to exactly what that Drax as a large, certainly first of a kind in the UK BECCS facility is actually doing. I think, speaking for myself, the UK needs to develop we need to develop our carbon dioxide disposal capability in the North Sea. We've got a fantastic resource in the North Sea to be getting rid of CO2. And if the only way of doing that is for the government to license Drax and pretend it's a negative emissions power plant, it's kind of, for me, that's kind of worth the prize, if that's the only way of doing it. There's a much better way. It's called carbon takeback. And if you come back here tomorrow, I can tell you all about it. But right now, we are in the mindset of finding big projects that allow us to do things in the UK. And Drax seems to be the price of that Humber cluster. And since I'd rather the Humber cluster happened than it didn't, sorry, I'm starting to rabbit on a bit here, but Wolfgang may well have a stronger view on that.
Wolfgang, go ahead.
Yeah, as Miles already pointed out, there's a diversity of views on it. My scientific assessment is that Drax is dangerous and it should be shut down. Basically because it can claim to be carbon neutral when it's not, because it emits more CO2 using biomass than if it burned coal. And so Miles was talking about coupling that with CCS, but then the question is, why would the source of that CO2 have to be biomass? So as it is operating right now, and here in Germany and all over Europe, coal plants are planning to go the biomass route on the basis of the argument, but it goes back, so it's CO2 neutral, and then they get all these subsidies and they can be called green and sustainable and all that. But the real issue is where and when does that biomass grow back? And the truth is, it grows back slowly over time. We cannot harvest biomass sequestered in or grown in the past because the CO2 sink of the land surface is already figured into the Paris climate targets. And there's very few additional biomass on that on any scale. So the danger is if that ramps up globally and a biomass market is supplied, then suddenly biomass is a valuable energy commodity, and then it will be the new frontier of plundering the biosphere, and everybody's going to sell their biomass once there are a lot of takers. And the effect is that for several centuries, more CO2 will come out of those stacks as if they had, in comparison to if they had burned coal or gas, unless you couple it with real CCS and storage. But then why do you want to do that with biomass? So we have published on that in Nature Climate Change in 2018. We've written letters signed by 800 scientists back then to the European Commission because of the wrong regulation that this has in the Renewable Energies Directive. And just this year, we have written to President Biden and Ursula von der Leyen and the prime ministers of Japan and South Korea. And these letters were signed also by 500 scientists making these cases. So that's my analysis as a carbon cycle scientist, that biomass is a valuable commodity on this planet. It takes, it requires water and space and care, and it goes slowly. So it's not the route to go, except for maybe small local applications, but not on an industrial scale. There's no sourcing for that is sustainable. That's my opinion.
Kathy, do you have anything to add to that?
Well, I know there are many opinions about bioenergy, but I think we need to always look at it case by case and think about the local conditions. But as Wolfgang said, the large scale solutions, of course, have risks that need to be assessed. Yeah.
Can I just make it clear? I completely agree with you, Wolfgang. On unabated biomass, it makes no sense whatsoever. So bioenergy directly. Now, so as I was saying, you could probably put, you could end up with as good a climate outcome if we kept Drax as a coal-fired power station and fitted CCS to it when they first started talking about it like 20 years ago. We'd probably actually ended up with a better climate outcome. So but if it's the price of getting that CCS infrastructure built, it may be a slightly mad price, just as Elon Musk using carbon direct air capture with geological storage to offset his space travel seems a little bit mad to people. If it gets the technology developed, maybe we need to sort of accept some compromises here because we need that technology for the future.
Yeah. Before we wrap up, I know we're running a little bit over time. Are there any other questions? Yes.
IHS Market, we report on the energy industry. I was just wondering, how far down do you think the costs of direct air capture can get in terms of on a per ton basis? Do you think we can get down to like $100 a ton by 2030, say? And where do you see investment in direct air capture coming from over the next few years? Do you think it will be driven by billionaire family offices, or do you think governments are really going to step up in terms of research and development? Thank you.
So I think it could be got down to the $100 a ton level by 2030, but only with a very substantial resource push and development push with lots of new money being thrown at it, beyond what I think even the billionaires can afford. So that's why I think we need to be recognizing this transitional pathway. So if anybody has a net zero strategy, whether it's a country or a company, and it doesn't contain a steadily increasing element of direct air capture and permanent storage, then if they're still using fossil fuels, they're kidding themselves because they're not on a path to neutralizing the climate impact of those fossil fuels. I'm afraid this is where Wolfgang and I disagree. Not accept a company just saying, don't worry, I'm going to stop using fossil fuels in 2049. So I'm a net zero 2050 company. That's not acceptable. If you're using fossil fuels up until the 2040s, you need to be investing your resources into making those fossil fuels safe for the future of our planet. And so we cannot just allow companies to get away with saying, we're going to walk away, it won't be our problem. And we can't afford countries to do it either. And I think there is a danger that the European Union as a whole is maybe planning a fossil-free future, knowing perfectly well that the rest of the world will still be using fossil fuels. And then they'll say, yeah, okay, the climate's changing, but it's not us, it's somebody else, they're the bad people. Okay, and this is where I'm starting to get a little bit angry, but that is not a solution. That doesn't solve the problem. So if we got a recognition in our policies that we need this, and we get that transitional pathway built in, so that we have a financial drive into these technologies, yes, we can get the costs down. If you look at the numbers, we can get it down to that $100 a ton level by 2030, but not with the kind of way we're trying to finance it at the moment.
Okay, it's over time, but I'll ask one final question to our panelists here. What would be your one sort of policy ask when it comes to carbon dioxide removal?
I think you've heard mine. You've heard mine. So over to Wolfgang and Kathy.
I'll ask Kathy and Wolfgang, what were your policy asks when it comes to carbon dioxide removal? Having had this discussion about the fact that it might be constrained in some way, it might get in the way of emission reductions. How do we make sure that we maximize the deployment of carbon dioxide removal and enhance climate action in general?
Well, the NetGen project's overall view, I think, has been that we would need a separate target for the negative emissions and then a separate target for the mitigation. So then we could maybe lower this risk that with negative emissions we might somehow end up harming the mitigation actions. So.
Yeah, from my side, a thought and an ask. I want to pick up that thought on intertemporal justice. You might know that the German Supreme Court said that it's unconstitutional to burden the future generation with not enough carbon budget, so that they either will have to suffer restrictions in their freedoms because of the impacts of climate change, or they will have to burden, mitigation efforts that are just unbearable. So our generation, this decade, actually it's not generations, it's decades, this decade has to do its fair share. So I wonder whether that not also applies to some extent to CDR and future technologies that we build on. So it's really about, can we offload some of our reductions on them and expect them to find technological solutions? So my thought and my question is it more challenging to construct these CDR technologies on a huge planetary scale, or is it more challenging to put solar panels on every roof on this planet? Is there something dishonest in saying we cannot go fast enough with the renewables, but somehow we're optimistic about all the stuff involved with the CDR? So probably the answer, of course, is a little bit more complicated. There's a certain mix of the two that is required. But I think we should not let ourselves off of the hook too easily with the push for renewables, while being pessimistic about our renewables technology and optimistic about the CDR technology. Now the ask I have is the same that Kati has. I think politically the most important thing is to have transparent accounting, so separate mitigation targets, CDR targets as part of that, or like additional to that, and then also separation of what we do in our own territory and what we want to do overseas with others. And if those things are transparent, then they can be discussed. And then, of course, it all comes down to market designs and political agreements. People in Germany, parties have been claiming all the stuff that they're going to do overseas and all the CDR that they're going to have. And that's why they're all on a 1.5 degree path, even though I think they're not. But it has to be transparent in order to be so we can discuss it. And then the next step is, of course, what Miles was talking about. How do you design the markets and the incentives and the pathways and the monitoring and the certification in such a way that it does not lead to ill-advised market developments, but it actually leads us to where we need to be? And that's a very complex question that Miles can talk about much better than I can.
And if I might say, my single policy ask is that if the people who pay for the technology development for CDR should not be the taxpayers or the people who might otherwise be paying for adaptation. We need to place the burden of developing these technologies firmly on those who benefit from using fossil fuels. That's the principle of carbon take back. And if you come back here at 2 o'clock tomorrow, you can hear us all talking specifically about how we hold the fossil fuel industry to account and apply the principle of producer responsibility to the fossil fuel industry itself. Sorry, I couldn't resist that opportunity for a bit of shameless advertising.
Great. Well, thanks a lot, Kati, Wolfgang, and Miles. We have a quick round of applause for panelists. Thanks for joining. We have another event at 4 o'clock on guiding principles for carbon dioxide removal. We'll be in the same room. So for those online, it'll be a different stream. It'll be called Guiding Principles for Carbon Dioxide Removal. Great. Thank you very much.